Good morning, grade 9s. Today we're going to start working on an area called exponents, and these are the exponent laws. There are two lessons. The first one is 2.4 and the second one is 2.5. And this is to prepare you for two more units coming down the road, which are the polynomial unit and of course your algebra unit. Now in grade 6, 7, and 8 your use of exponents was actually very limited, but today we're going to continue working with that, and we're going to have you start with the product of powers, quotients, power of power, power of product, and power of quotient. These are all the names of the laws that we're going to be working with. I'm not going to expect you to know what they are, and I don't want you to worry about memorizing them. What I want you to do is I want you to be able to use them, and you'll understand as we go forward. There is another law which is called the Negative Exponents Law, and we'll cover that when we get to it. Now there's something we have to talk about first, and that is the important warning for this unit. In this unit you have a calculator, and if you know how to use your calculator, you can use your calculator to find the answer. The problem with that is that it only works when you're using numbers. Right after we're done this, we're going to work in variables. Now you may be able to put 2 to the power of 6 times 2 to the power of 7 in your calculator and get an actual number at the end. But how are you going to put x to the power of 6 times x to the power of 7 in it? You simply can't. So you have to learn the process. All right? If you try to just jump to your calculator, you're going to be totally lost. And since there's two more units coming up which is going to use all these laws, my recommendation strongly is only use your calculator as limited as you want. Okay, so let's talk about the first one. It's called the product of powers. We know that powers are numbers that have bases and exponents, and which they model repeated multiplication. For example, if you take a look at 3 to the power of 4, the base is 3, the exponent is 4, and what this means is you take the base, 3, and multiply it by itself 4 times. So that would mean you would get 3 times 3 times 3 times 3. This is what we refer to as a product. Now the second piece of information we have to review is whether or not brackets will affect the multiplication of numbers when all the numbers are the same. Okay, let's take a look at the effect of brackets here. I've got two expressions here. I've got 3 times 3 inside brackets times 3, and then I've moved the brackets over to the second pair of 3's in here. Now whenever we do an expression like this, it's always bedmass, right? Which means that the b is first, the brackets, so this would be 9. And of course we have times 3. Over here this would be 9, and then of course we have 3 on the front times 9. Well, 9 times 3 is 27, and 3 times 9 is also 27. So what this means is that they're both 27. So as long as we have the bases all the same, all 3, and the base is all the same over here, all 3, the placement of brackets does not matter. Now remember, we're working with exponents, so they're multiplied by themselves, so we're working only in multiplication. Okay? So we know that brackets don't affect the actual answer. Let's take a look at the product of powers law. Now the product of powers law is a rule that shows how to multiply powers that have the same base. Now this is the most critical thing you can learn in this lesson. If they have the same base in multiplication, then the product of powers law works. If the base is different, then it does not apply. So let's just do an example here. What is the product of 2 to the 3 times 2 to the 4? Well, 2 to the 3 is 2 times 2 times 2. So that means we would get a product of 2 times 2, which is 4 times 2 is 8. Now what is the product of 2 to the 4? The product is 2 times 2 times 2 times 2. The base multiplied by itself 4 times. So when we multiply these two powers, let's see what happens when we put them all together. Now notice that they're all the same base and they're related by multiplication. So that means we know that this is going to be 2 times 2 times 2 times 2 times 2 times 2 times 2. Right? So we have 7 of them. Right? It doesn't matter if the brackets are in or out, because we know from up top here that brackets don't affect the answer. So now place this product in power form. You have 2 times 2 times 2 times 2 times 2. There are 7 of them. The base is 2, so this becomes 2 to the power of 7. So you should notice something here. The fact is that the number of 2's was just counted up and added together. When you talk about the exponent, the exponents were just added together when you multiplied the powers with the same base. All right, so we had, if you go back here and take a look down here, what we had, you'll notice that 2 to the 3 times 2 to the 4 was 3 plus 4, which got us 7 2's. Okay, let's take another example here, and maybe this will come clearer for you. Okay, 4 to the 2 times 4 to the 3. Well, 4 to the 2, when you put it in product form, is 4 times 4. 4 to the 3 is the base times itself 3 times. That's 4 times 4 times 4. If you get rid of all the brackets, you have 4 times 4 times 4 times 4 times 4. So there's 1, 2, 3, 4, 5. So you're multiplying the base by itself 5 times, which means you have 4 to the power of 5. Okay, I want you to try this one. 5 to the 6 times 5 to the 1. So pause the recording and do it. Alright, now we have 5 to the 6, which is 5 times itself 6 times. We have 5 to the 1, which is 5 by itself, because there's only 1 there. When you take all of this together and you remove all the brackets, you'll notice we have 1, 2, 3, 4, 5, 6, 7 of them. So this becomes 5 to the power of 7. Now what I'd like you to do is I'd like you to write out in your own words what we did here to get from 5 to the 6 times 5 to the 1 all the way to 5 to the 7. What happened to the exponents? So write that down in your own words, pause the recording and do that right now. Alright, so this is what you should have written. First thing you have to do is make sure they have the same base, 5 and 5. You have to make sure that they're working with multiplication. Alright, and secondly, we should know that if you multiply two bases by themselves, which are powers, you add the exponents. That's what this is over here, add the exponents. And you rewrite the power with the base and the new exponent. So if you want to look at this in terms of algebraic terms, if you have the same bases, A, and the first exponent is m, and the second exponent is n, to multiply a to the m times a to the n, all you do is take the a and you add the two exponents. So the base remains the same, and the two exponents, they're added together. Okay, what I'd like you to do now is I'm going to do the first one for you and then show you the process, and then we'll show you how we're going to mark it, and then I want you to finish off the last ones here. So 4 to the power of 4 times 4 to the power of 2. You'll notice that I've done the work here, 4 to the 4 plus 2. I showed where the 6 came from. It wasn't just straight 4 to the 4 times 4 to the 2 gives me 4 to the 6. There's a work step right here. And that work step proves to me that you know how to multiply these two exponents, these powers, sorry, together. So if I was marking this, you would get, it was an assignment, you get, write the question down, write the answer, the work, and the answers. It's always question, work, and answer. So this one here would have been 3 marks. Okay, so pause the recording, and I'd like you now to complete these 3 expressions showing your work. So pause the recording and do that now. Alright, taking a look at the first one. 10 to the power of 12 times 10 to the power of 3. Just checking, the bases are the same. We're multiplying, so it's going to be 10 to the power of 12 plus 3. And of course 12 plus 3 gives us 15, so I don't know why that's a 13 there. It should be 10 to the power of 15. Alright, so fix that right there. Alright, now the second one, 3, which is negative, it's inside brackets, so the whole base is negative 3. Remember that, because if this was negative 3 with no brackets to the power of 4, the base would be a 3. Alright, because this would be like subtracting a 3 to the 4. So the base is 3. The moment you put brackets around that, now we've got a positive, which would be like plussing negative 3 times itself 4 times. We'll get more into this stuff later. So we've got negative 3 inside brackets times negative 3. So that's going to be negative 3, and the 4 and the 5, they add together, giving us negative 3 inside brackets to the 9. Now remember, don't lose the brackets in this case. The brackets show that the base is negative 3. The moment you drop the brackets out, the base changes from negative 3 to positive 3. So you have to keep the brackets whenever you have a negative. And of course 8 to the 0 times 8 to the 3 is 8 to the 0 plus 3, which is 8 to the 3. Okay, so that's the first law. The second law is called the power of quotients. Well, if the power of products is multiplying, and we know the result of multiplying is called product, then the result of dividing is called a quotient. We know we're going to be dividing here. So let's review a simple concept. What is the result when a number is divided by itself? So if I have 5 divided by 5, I get 1. It's always 1. Anything divided by itself is 1. Now let's expand this a little bit and take a look at our first set of examples here. 2 times 2 in the numerator and 2 in the denominator. Now 2 times 2 gives me 4, and 4 divided by 2 gives me 2. Now remember, you have to do the numerator first, because when we're doing multiplication and division, you do it in what order that it appears, and because the numerator has multiplying in it, you multiply first, then you divide. Now what I want to do is I want to change this slightly. Okay, I want to take 2 times 2 and we're going to change it like this. What if I slid this 2 over underneath the first 2? Right? Now I'm going to put this on hold. 2 divided by 2 is 1. And of course 1 times 2 is equal to 2. Notice that the answers are the same. This here is called canceling out or dividing out. And that's when you move a 2 over. And remember, you can only cancel out 1 to 1, like a 2 on the top, 2 on the bottom. If it was anything else, you couldn't do it, like a 2 and a 3 wouldn't work. Okay? Now, is the result the same when you look at the 2 here and the 2 here? Yes. All right. Let me show you another example. 3 times 3 times 3. Putting that into exponent form means that the base is 3, and there's 3 of them multiplied together, so that's going to be 3 to the power of 3. And that's 27. Right? And 27 divided by 3 gives me 9. Second possibility, or second one. If I move the 3 over and I take out this 3, right? So 3 3's, take away the 1 3, gives me 1 times 3 times 3, which is 9. Same thing. So is the quotient the same? Yes, it is. So take a look at these two examples, because this can help you in canceling out later on when we have just variables. If this was an m and this was an m, you could just cancel out the two m's and they become m divided by m, and of course anything divided by itself is equal to 1. So it doesn't matter what it was, as long as you divide it by itself, you get a 1 there. So that would cancel out those two variables if they were m's. Okay, what about the following? Now I've got 4 4's on the top and 2 4's on the bottom, right? Well, slide the 2 4's over. Right? And this one and this one cancel out, giving you 1. Right? 4 divided by 4 is 1, and 4 divided by 4 is 1. So I have 1 times 4 times 4. Well, 1 times 1 times 4 times 4 is 16. All right? Now, if you look at here, we had 4 4's, and we removed 2 of them. Right? Go back here. What happened down here? We had 3 3's and we removed 1 of them. Right. The answer in both cases stays at 16. So now let's apply this to the power of quotients. 2 to the 2 divided by 2 to the 1. We're going to rewrite this as a fraction, because we know that divide is simply a fraction. A fraction is the divide question you haven't done yet. All right? And that's why you look at a divide symbol. You've got a number there and a number there. That's division. That's your divide sign. Right? It's a fraction. All right? Now, taking a look at this, 2 to the 2 divided by 2 to the 1. If we expand the powers into a product form, we have 2 times 2 over 2, which gives you, dividing out, what? These 2 right here. So those move over, cancel out, and you get 2. So again, we had 2 2's. And we removed 1 of them. Now, let's place the quotient into a power form. And you get a quotient of 2 to the 1, right? This power here is actually 2 to the power of 1, because there's only 1 2. So if you take a look at this, you should have noticed that 2 times 2 over 2 is 2 to the 2. And then 2 to the 1 down here, but the 2 up here have 1 taken away. And that got us 2 to the 1. Now, maybe a little bit fuzzy just yet. Let's try another one and see if you notice it. There's our fraction. 4 to the power of 4 over 4 to the power of 2. All right. If I do this as products, 1, 2, 3, 4 on the top, 2 on the bottom, so 4 of them, removing 2, 4, removing 2, these would cancel out to become 1's, 1 and 1, times 4 to the 4. Right? And of course, 4 times 4 is 6. Is 4 to the power of 2 here. The bases are the same. Putting it back into exponent, you get 4 to the power of 2 here. So 4 to the power of 4 divided by 4 to the power of 2 is 4 to the power of 2. 4 bases on the numerator. the 2 bases in the denominator, 4 of them, take away the 2 that cancel out, gives us 4 to the 2. Now, understand here, when you cancel something, it doesn't disappear. It becomes a 1, right? And of course, anything times 1 is itself, so some people, some professors tell you that this just cancels out and goes away. But it doesn't. It's still there, because you can't change a question by removing something halfway through. It has to be in the question right to the very end. And if this becomes 4 over 4, that becomes a 1. It's still there. But the only thing is that it doesn't affect anything. So really 1 times 1 is 1, and 1 times 4 is 4. So really the 1s don't have any effect on your final answer. One last example. 3 to the power of 6 over 3 to the power of 4. Now I want you to do is like you to try this one on your own. See if you can figure out what the answer is in exponent form, in power form, okay? So pause the recording and do that right now. All right, let's take a look. First off, let's put this in exponent form. Oh, sorry, power form. 3 to the 3 times 3 times 3 times 3 times 3 over 3 times 3 times 3. And that means we have 1, 2, 3, 4 of them canceling. Notice the 4 down here. So we had 6 on top, 4 in the bottom. The 4 in the bottom canceled out 4 of them that were on the top. So 6 take away 4 gives you just 3 times 3 left over, which is 3 to the power of 2. So if I have 3 to the 6 divided by 3 to the 4, I get 3 to the 2. Now what I'd like you to do is, like you, in your own words, to write down what you think the power rule is when you divide powers. So pause the recording and write that down. All right, so here's what you should be taking. When dividing powers which have the same base, that's critical. If they don't have the same base, none of this applies. All right, so if they have the same base, you can just subtract the exponents. 6 take away 4 gives you 2. So 3 to the power of 6 divided by 3 to the power of 4 becomes 3 to the power of 2. In algebraic form, it looks like this. The bases are all the same. We're dividing. So a to the m divided by a to the n means that you just take the m and the n and you subtract them. Now remember, order is important, so this becomes m subtract n. So the answer is going to be a with m subtract n as your exponent. Okay, here you go. There's some examples for you. Let's do the first one together, and then you can do the last 3. 6 to the 7, divide by 6 to the 3. You're going to take the exponents and you're going to subtract them. 6 to the 7, take away 3. Now remember before, this is our work step. So there's your question, work, and the final thing is 7 take away 3 is 4, so you have 6 to the 4. So that's how you do it. Question, work, and there's your answers. This one would be out of 3 marks. Okay, do the next 3, please. Pause the recording and get them done. All right, let's take a look. So, negative 3 to the 14 divided by negative 3 to the 4. Remember, the bases are the same here. The brackets are including the negative here. So this is negative 3 divided by negative 3 inside brackets to the 4. Now, you got to be careful here, because if you didn't have brackets in the first one, then the bases would not be the same. So for example, if I had negative 3 to the 14 divided by negative 3 inside brackets to the power of 4, this looks like the bases are the same, but they're not. Okay? Because there's no brackets here, the base here is 3. So this is a subtract 3 to the 14 divided by negative 3 to the 4. The bases are not the same here. You have to keep the brackets in the expression. Now, take a look. We have negative 3. We subtract 14, take away 4, which gives you negative 3, including the brackets, to the 10. 14 take away 4 is 10. 9 to the 32 divided by 9 to the 22 becomes 9 to the 32, take away 22, which is 9 to the 10. And 8 to the 13 divided by 8 to the 10. This is 8 to the 13, take away 10, which is 8 to the 3. Now you notice that every time we did this, all of our exponents were positive. This is because in grade 9, they don't include the negative exponent law. So if I had reversed something here, like say it was 8 to the 10 divided by 8 to the 13, look what happens here. We have 8 to the 10 take away 13. Well, 10 take away 13 is a negative number, so we get 8 to the negative 3. Right? Now, we'll show about this later, but you have to understand that order is important. Because the exponents here are not the same as here, you get a completely different answer. Right? All right, let's move on. It's time to take things a little bit more complex. So what I'm going to do here is we're going to start working with three terms in our multiplication, 3 terms in our division, and the first one's multiply and then is divide. Remember, you're doing order of operation. Now you can combine things if they're the same. So for example, you see multiply and multiply. You could do all of the work with these exponents in one step. Right? Down here we have 4 times 4 to the 5, so 4 to the 4 times 4 to the 5 means these two can be added, but then you're going to divide by 4 to the 3, which means you're going to add these two, but you're going to subtract that one. Right? So I'm going to go to here. This becomes 4 to the 4 to the 4 plus 5 minus 3 gives you 4 to the 6. 4 plus 5 is 9. 9 take away 3 is 6. Okay, I'd like you to pause the recording and take a shot at these 3 questions here. Okay, going back up to the first one, 3 to the 4 times 3 to the 7 times 3 to the 8 means that these are all related by multiplication. The bases are all the same, so I just have to add 4 plus 7 plus 8, which gives me 3 to the power of 19. Down here, I've got 7 to the 6 times 7 to the 2 divided by 7 to the 3. Now remember, order of operations, numerators and denominators are calculated separately. You only divide at the very, very end. So my first goal is going to be 6 and 2. So that's going to become 7 to the 6 plus 2, and I'm just going to hang on to the 3 down here for the moment, the 7 to the 3. 6 plus 2 is 7 to the 8. Now I've got the division part to do here. When we divide powers which have the same base, you take and you subtract the exponents. This becomes 8 take away 3, so your answer should be 7 to the 5. A little bit more complicated one. 10 to the 3 times 10 to the 5, we're relating by multiplication, so these will be added. This one's dividing, so this one's going to be subtracting. So I'm going to have on the top 3 plus 5 subtract 2. Now on the bottom I've got 1 times 10 to the 3 here, 10 to the 1 times 10 to the 3, so I'm going to add the 1 and the 3. That gives me a numerator, which is 10 to the 6, and a denominator, which is 10 to the 4. Now I can divide them out. 10 to the 6 take away 4 gives me 10 to the 2. So there's some things here you have to really put into your brain and keep them there. These are when can you use it and when can you not use it. This is critical because if you try to apply the laws when they're not supposed to be applied, you're definitely going to get the wrong answer. All right? When can you use the power laws to simplify an expression? Okay? They have to have the same base and they have to involve multiplication and or division. So if I take a look here, 2 to the 3 times 2 to the 5 gives you 2 to the 3 plus 5, which gives me 2 to the 8. Notice the bases are the same and we're related by multiplication. So when can you not do this? Well, if you take a look here, it says you can't do it when we're doing addition or subtraction. So 2 to the 3 plus 2 to the 4, because they're not related by multiplication, these two things can't go together. Right? If you just do the calculations, you'll find out that 2 to the 3 becomes 2 times 2 times 2, which is 8, and 2 to the 4 is 16. Because they're related by multiplication, 8 plus 16 gives you 24. Now go up here. 2 to the 3 is 8, and 2 to the 5, well, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So this is times 32. Right? So what this ends up giving me is 8 times 32, and it's very easy to see that 8 times 32 is not going to be 24. Okay, let's see if you can do these questions. So pause the recording, and I'd like you to do these two questions. I'll help you out with the first part just so you understand what I'm talking about. In simplified form, your answer at the end has got to be in in an exponent form. All right, and then evaluation is your final answer. So 2 to the 6 divided by 2 to the 4 plus 2 to the 2. This is important that you understand this. 2 to the 6 divided by 2 to the 4, that's 2 to the 6 take away 4. And 2 to the 6 take away 4 gives me 2 to the 2 plus 2 to the 2. Now these cannot go together because this is adding. It only works when they're multiplying. So when we do our actual evaluation, 2 to the 2 plus 2 to the 2, well, 2 times 2 is 4, and 2 times 2 is 4. 4 plus 4 means our final answer is 8. So let's have you try this one. Pause the recording and give this one a try. All right, so what I'm going to do first is we're going to deal with the first term. Okay, I've got 4 times 4 to the power of 5 times 4 to the power of 2 divided by 4 to the power of 2. Now there's an adding here. Now that adding blocks these two things. They're separate now. This is one thing, and that is something else completely. These two things can't go together. Right? So we have the top 4 to the 5 times 4 to the 2 gives me 4 to the 5 plus 2. That gives me 4 to the 7. Now 4 to the 7 divided by 4 to the 2 means this becomes 4 to the 5. Now this becomes 4 to the 5 plus 4 to the 2. These two things cannot go together in terms of simplifying. 4 to the 5 times 4 to the 2, well, 4 times 4 times 4 times 4 is 1024, and 4 times 4 is 16, so your answer is 1040. All right, so here we go. Here's a bunch of questions for you. I'd like you to take these two, pause the recording, and do these two questions. All right, let's take a look. What can go together and what can't? Well, if you notice, this is 2 to the 7, and this is 2 to the 3. The bases are the same. So as a divide, so this can be put together. Now there's a plus here. Now that plus separates this from this. So I can do the first pair of 2's, I can do the second pair of 2's, but I cannot put them all together. So taking a look at that, our first one is 2 to the 7 divided by 2 to the 3. When we divide powers that have the same base, you subtract the exponents, so this becomes 7, take away 3. When you multiply powers that have the same base, you add, so this is 4 plus 2, so that becomes 2 to the 4, because 7 take away 3 is 4, and 2 to the 6, because 4 plus 2 is 6. Now this adding means you cannot put the 4 and 6 together. Those are separate. So that becomes 16 plus 64, which is 80. Okay. Now again, you can put this in your calculator, but it's going to lose a lot of marks. If this was a question in your assignment, write it down, do the two works, get the two works, get the two answers, and get the answer. So if I was doing this in an assignment or on a test, you would get a mark for all the work. So you have potentially 1, 2, 3, 4, 5, 6, 7, 8 marks here. If you just put this into your calculator, it's going to spit out 80. So you would get a mark for putting the question down and a mark for 80. So you have got 2 out of 8 marks. All right? Work is far more important than the answer. The answer is just the last line. I can take this work here, and once you understand it, I can take all of these and turn them into variables, right? M, 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 and M, and you would get at the end M to the 4 plus M to the 6, and that would be your final answer. You can't put that in your calculator. All right, let's go to the next one. I've got the top 4 to the 5 times 4 to the 3 divided by 4 to the 4. No adding or subtracting in my numerator, so that means that my numerator is going to be 4 to the 5 plus 3 minus 4. 5 plus 3 is 8. 8 take away 4 means I have 4 left over. On the bottom, the bases are all the same, related by multiplication and division. There is no adding or subtracting here, so it's just going to be 10 plus 6 take away 8. And of course 10 plus 6 is 16. 16 take away 8 gives you 2 to the 8. Now 4 times itself 4 times, and 2 times itself 8 times. Well, 4 to the 4 is 256. 2 to the 8 is 256. Anything divided by itself is 1. So your final answer is 1. So I was marking this. You put the question down. You have your numerator work, your denominator work, your numerator result, your denominator result. You do your dividing, and you get your final answer. 1, 2, 3, 4, 5, 6, 7 marks. Each one of these pieces of work is important. All right, final one. Give this one a try. Pause the recording and do it. Okay, well, first thing I notice when I'm going through here is that I've got a set of brackets, square bracket there, and a square bracket there. So this is all divided by this. That means that we've got a numerator and we've got a denominator. So I'm going to take the numerator, and that's negative 3. Everything is in negative 3 base here, so it's going to be 4 added 7 minus 7. Right? And that whole thing here still has to be divided by negative 3 inside brackets to the 2. But I'm going to work out the numerator first. 4 plus 7 is 11. Take away 7 is back to 4. So we have 3 to the 4, negative 3, sorry, to the 4 divided by negative 3 to the 2. Now that my numerator is completed, I can now go and put these two together. 4 take away 2 means that I've got negative 3 to the 2, and of course anything here, when you multiply it by itself when it's a negative times negative is a positive, right? And of course 2 means you go negative 3 times negative 3, your final answer is going to be positive 9. Okay, so your teacher will now assign you your assignment. Good luck, and if you have any questions, watch the video again.